Good morning and welcome to the third webinar in Take Action's Inside Weed Management webinar series. My name is Zuhur Ganai and I'm your host for today on behalf of United States Herbicide Resistance Action Committee and Take Action. So United States Herbicide Resistance Action Committee is an industry group operated by technical members of the companies represented in the CropLife America. US HRAC has a mission to fight herbicide resistance and create awareness about integrated weed management systems and to promote proper product stewardship to delay the evolution of new herbicide resistance issues. So US HRAC achieves these goals by involving in regulatory engagement with US regulatory agencies to refine and communicate herbicide resistance management for regulatory requirements and initiatives. And HRAC partners with key stakeholders such as Global HRAC, Weed Science Society of America, regional weed science societies, and partners in academia and ag associations, commodity groups to engage in herbicide resistance management programs, research and development of educational information. And finally, US HRAC engages in the communication of these aligned technical information to educate influencers, growers to manage herbicide-resistant weeds more effectively, and by supporting programs like this webinar and promoting use of herbicide mode of action app and many other programs. This webinar and all three webinars in this series are brought to you by US HRAC in collaboration with Take Action. Take Action is a farmer-focused educational platform designed to help farmers manage herbicide, fungicide, and insecticide resistance. The goal of this group is to help farmers like you, like most of you, to adopt management practices that reduce the impacts of resistant pests and preserve current and future crop protection tools and technologies. The program is an industry-wide collaboration, including representatives from major ag chemical companies, commodity boards, and agricultural industry organizations like HRAC. We thank them for their support. And Take Action is also supported by land-grant university researchers and extension specialists like Kevin Bradley, who you will hear in just a few minutes. They provide a majority of the content and background information for resources Take Action produces. So we are grateful for their contribution to this program. So our presenter today is Dr. Kevin Bradley from University of Missouri. Kevin Bradley is a professor and state extension weed scientist in the Division of Plant Sciences and Technology at University of Missouri. Kevin's faculty appointment includes extension and research responsibilities in the area of applied weed management in corn, soybean, wheat, pastures, and forage crops. Since his arrival at University of Missouri in 2003, most of Kevin's research and extension efforts have been focused on development of integrated programs for prevention and management of herbicide resistance in weeds, specifically Waterhemp. He also teaches a graduate level class and has served as major advisor to 25 graduate students since his arrival at Missouri. And with that, I will turn it over to Kevin. Please go ahead, Kevin.
Well, thank you, Zuhur. Thanks everybody for tuning in today. We are going to talk about a little bit of a different topic, I guess, than what we've seen so far, but that's okay. And what I mean by that is that harvest weed seed management is kind of new to the US and really not adopted all that much so far, although I think that's probably going to change. And so it's this whole concept of, you know, instead of letting weed seed go back into the soil, you know, perhaps we can do something to eliminate those seed from ever being deposited on the soil. So we're going to just cover 2 or 3 of these different things that we've been looking at in the state of Missouri, but I don't want to rule out all of my many colleagues that have done great work and are doing great work on this same topic all around the US right now. So before we get into those though, just a little bit about why we would ever even look at this. Some of these things we're going to be talking about. I think one reason is because we are kind of spoiled. We have been kind of spoiled in agriculture with our weed management. I guess it's the fault of how successful we've been at being able to in the past get good weed control with herbicides, and so that kind of mindset is still pervasive throughout our agricultural clientele. And I'm certainly not saying that herbicides are going to disappear as a method of weed management. I think they'll continue to be one of our methods of weed management for years to come. But we've gotten to that mindset, and certainly our growers, their first, for the most part, our growers, their first line of defense is what herbicide can I use to control that particular weed. Another mindset kind of thing that we haven't been able to get out of so far, as I have seen, is this thing called techno-optimism, and that just simply means that we've always had something come along that's able to solve the problem of resistant weeds, and it just makes you wonder how long that can be sustainable, because I myself personally have seen just about everything under the sun come along as the next answer to resistant water hemp, for example. And within a few years or so, then of course, water hemp evolves resistance to that, and it becomes no longer effective. And so that's the last point, I guess, here in this last bullet is there's a bit of depressing news here that we have resistance now to 7 different herbicide sites of action in water hemp, 9 different in Palmer amaranth. It just doesn't seem like a very sustainable solution as herbicides alone. And so we, around the US, university weed scientists particularly, are looking at other options and looking at this whole concept of preventing weed seed from going back into the soil. So there's a couple of different ways, a couple of different implements that you can do that with. And so today I'm just going to briefly share some of the results we've seen with primarily 2 of these different approaches. And so one of them is shown here, and this is a electrocution device. It's called a weed zapper, and this is obviously a small unit for our research. I think they do make these up to 40 feet in width, but still obviously probably not something that's getting used in conventional agricultural systems yet. Electrocution of weeds is not new. This is something that's been going on to some degree since the 70s. At least this probably the first mention of it was then, when there was some research done primarily in the specialty crop industry and primarily in the organic industry. And so our approach to this was just to see, well, could possibly this have a fit in the future? And so in not only in the future, but in future conventional agricultural soybean or perhaps even cotton systems, for example. And so what I mean by that is the concept here that we have been evaluating is basically, can we go and use this device when there's a height differential between the crop and the weeds in July or August? These would probably be evaluation of escaped resistant weeds, which we have plenty of problems with. And so that's kind of what kind of results we're going to show you today. But before we get into all of that, I mean, the basics of this is there's a generator on the back, which you see there, a PTO driven generator, and on the front there's a boom. And this particular picture is probably not the best. It's pretty low down there. This was done on just kind of a bare ground situation with this particular trial that we were doing in that case. But so there's a boom that's a solid bar that anything that boom contacts, it electrocutes. And And so obviously this is designed, and this particular implement is designed for having some kind of height differential between the crop and the weeds. So obviously this is not really weed management. This is weed control. This is killing weeds that have escaped. And do we have a need for that in many of our systems? Absolutely. And if you can kill it and prevent it from producing seed, then in that way it is one form of harvest weed seed management. And so this is just a little video showing that device going through the field. You can see it sparking here and there on some water hemp and all that. So obviously this wasn't in one of our soybean trials. This was just bare ground to get some good video. But the premise is, you know, you're gonna electrocute those weeds, and it's a very quick kill, probably the quickest that you'll ever see. You can turn around and come back down the row and start to see some weeds wilting and turning brown. So really 7 days after treatment, or even a couple of days after treatment, you're probably going to see all the results you're ever going to get out of it, as far as how efficacious, how good it controls weeds. So my approach to both of the things I'm going to talk about today is pretty simple. I do have some data, but I have a lot of pictures and just comments. And so I think I have like 4 or 5 comments here about what we've learned about weed electrocution so far. And I would say there's still stuff that we have questions about that we'll be investigating this coming up season. So the number one thing, and I'll just put out there, obviously this is not for everybody. It's not just like going out there and jumping on a sprayer. There's considerable hazard here. It can be dangerous, and you need to stay away from this. And we couldn't have people operating around this. Obviously, our general practice is nobody gets within 50 feet of this when it's running. But there are several safeguards within the tractor itself that will allow you to kill this device immediately if anything were to occur. But just want to put it out there that this is different for sure. And I should say, you know, another real big difference between what was done in the 70s and what we have here today with these devices is a whole lot more electricity that's generated now with these devices compared to what used to be evaluated. So that's just one comment. The second one I would say about actual results and control, it's kind of opposite of what we would be normally preaching about for weed management with herbicides. This, again, I do not call this a weed management implement. I call this a weed control or weed escapes implement, because it's not going to be something that's real good on the smaller weeds. The bigger the weeds get, it tends to be better. And again, like I said earlier, it's from what I can tell, this is primarily something that might be directed towards escapes later in the season. So a little bit of data here. Try not to get too bogged down in the data today, but my student that's been running this project, that's going to graduate here pretty soon, Haley Schreier, this is all her data, and we have way more than I'm going to show, but these are just different weeds. As you can see, giant ragweed, horseweed, or some of you might call that mare's tail, and then water hemp. And I think the trend is pretty obvious as you go from right to left in either one of those. With either one of those weeds, you start to see the bars get bigger, which means better weed control. And so our results really back up the fact that you know, the weeds need to have some size on them for you to be able to get good control with this. The grasses, this is similar type of data, just with the grasses, barnyard grass and giant foxtail. Overall, I would say we've seen a little poor control on the grasses themselves, but the same trend is that we do get better control as they get bigger. I would say lucky for us in our research so far is just general statement. Lucky for us, this is an implement that does do very well on water hemp. Also, mare's tail is really good on giant ragweed, but there are differences in the level of control you get of different species, and we're still trying to figure that out. So this is not a one size fits all device by any stretch of the word. So this picture just kind of shows the kind of situation that we have evaluated this in. And so, you know, it's July, mid to late July, how many fields, or maybe even be August, how many fields in your area look like this where something has gone wrong, whether it's we sprayed the weeds too big, whether it's resistance and we didn't get an effective program. So whatever the reason is, you know, could we keep all of this from producing seed? So that's really where we're coming from with all of this. And so we, in addition to Haley's research, last year we got a multi-state grant from the North Central Soybean Research Board. And so we're able to kind of take this implement on the road and look at it in a variety of different environments in different weeds, but all of these were in soybean fields in that kind of situation that I just showed in that previous picture. And so we compared this to some other kind of non-chemical devices in many cases, but that was up to each individual state collaborator as to what the comparison would be. And so this is some of the results from that multi-state effort that another of my students, Jacob Vaughn, is leading this project. And so you see here, we do have quite a bit of variability in what we saw in water hemp control when you start kind of looking across geographies, and all of these trials were in soybean. And one of the things I would say here about why Illinois was poorer, pretty low control, I don't think anybody would be happy with that, is because it was the first site we went to. There probably was not, it was probably not the best timing for us to be there. There's probably quite a few of the water hemp in this case that were below the soybean canopy and grew out and didn't ever get contacted. So we're going to have to refine our methods next year and do a little better job at that. But anyway, you could see our range is quite a bit. And another thing you could see is the first time we were able to look at Palmer amaranth in some other areas, and it just doesn't seem to be maybe as good at controlling Palmer amaranth, but we still have a lot to learn there too as well. So, you know, just a few slides here of some of the multi-state data to look at and kind of confirm with you all what it is good on, at least what we know so far. And so again, we still see pretty positive results out of water hemp. I know it's not as high as many would like there, but we, you know, again, we're still investigating all the reasons why we might not get as good a control on a certain day compared to some other times we can go out there and get, you know, 100% control and all of that kind of thing. So more info coming in the future on that. But for the most part, we see, you know, it performing pretty well compared to, in this case, we compared it to rope wick applications. Again, part of this project was just to have a comparison treatment, and we had some rope wick applications of Enlist in this particular site. But every site did something different, and you know, again, that's not the purpose of what I'm talking about here today. But you can see here what the plant actually will look like inside and outside just 24 hours after electrocution. So probably quite a bit of cell damage and electrolyte leakage in the electrocuted plants compared to the non-treated. For whatever reason, you could see quite a bit of wilting and brown tissue for sure after this occurs. But, you know, while it may not have given us as good as we like on some of the pigweeds, and we're still working on that in Indiana with Bill Johnson and Brian Young as cooperators up there, it seems to really work well on the ragweed species, and that's something we had seen in some of Haley's work also. So, and then I would add to that, I think it is, there's not many times that we've done anything with it on mare's tail when it hasn't almost absolutely controlled all of the mare's tail. It works really well on mare's tail. Some other things we've seen is that, this perhaps we might need to go across twice, just depends. But, zapping sequentially is probably going to do better. And some of the organic people that are using this device have already seen that, and they do more than one pass. So, and then another very encouraging result is that we have electrocuted weeds of all kinds, but mostly water hemp, that have seed on them when we're electrocuting. So obviously a kind of a late season escape kind of situation. And we have seen quite a bit of reduction in the viability. This is some more of Haley's work. And so what you're seeing there, another way to look at this, because all of these bars are compared to the non-treated, what you would get out of the non-treated. So for example, the simplest math I can do, I'll go with even numbers. So this means that, ragweed would have a 80% reduction in viability, common ragweed, giant ragweed is 70%, so you can see that there is ability to reduce the viability of plants, of seed, from plants, that already have seed on them. So, and that occurs pretty often in August or so. You're going to probably start encountering a lot of plants that have seed on them already. And then the last thing before we switch gears, or the last comment, number 5, is if for some reason that your boom was contacting soybean when you're electrocuting in crop, you can cause yield loss. So I can kind of see both ways on this one. What we did, it's kind of written in this box down on the bottom left or bottom right. And that is that we basically did a worst case scenario, and I can kind of see the converse of this research, which would have been to not contact the soybean plants. And what I can tell you is, from what we've done so far, you shouldn't have to contact soybean plants when you're electrocuting water hemp escapes. We certainly have a numerous situation in the multi-state study where we really don't need to. But if you did for some reason have to contact those upper 2 or 3 inches of the soybean canopy, our results are showing that you can get yield loss of soybean themselves, which obviously is not anything anybody wants. But so it's kind of a weird way of saying that you should be fine in most cases. You don't have to contact the soybeans. You can keep that boom above it, and I wouldn't be concerned at all. But if for some reason the weeds were smaller, I probably would just not do it in terms of the likelihood of you getting yield loss by contacting that upper foliage. So that's what we know so far about electrocution, and it's kind of a new thing, and I don't know where it's going to go, where it's going to separate out. Something that's being researched in the second topic today, that's been a little more widespread, and I know some of my colleagues in Arkansas, in Iowa, and there could be other places as well that are actively investigating these on combine seed destruction devices. We have been able to do some research for the past couple of years with one, and that's what I'm going to try to talk about it from a whole US kind of standpoint, and not just our Missouri results. So if you don't know what in the world I'm talking about, these are devices that are implemented into combines, into the back of combines, using existing belts and pulleys and so forth, that have a hammer mill in their somewhere, depending on what brand and what product you talk about, and they grind up and kill weed seed. And we'll get to a little diagram that shows that in a second. But these are not new, but they are kind of new to the US. They're getting more attention every year. This is an Australian idea that basically started with resistance in ryegrass. And on the bottom of the screen, you can see one of the first prototypes, which was the Harrington seed destructor that was a pull behind in Australia. It was a pull behind the combine kind of deal. And of course that has evolved to integrated right into the combine. And we no longer have to deal with anything, that we're pulling. And so, like I said, what it does, and this was provided to me by Tom Barber, but you have chaff and that's containing the weed seed fraction, hopefully, that's entering into these. And there's stationary bars around the exterior with rotating bars in the interior. That's the impact mill or the hammer mill concept. And they're rotating at somewhere around 2,500 RPMs or so in our case, in our research with the seed Terminator. And of course, through that process, what we're hoping for is that you are getting weeds that are ground up or weed seeds that are ground up or damaged to such an extent that they are no longer viable. And so the question that obviously we had in our research and what everybody else is trying to answer right now as well is, well, as you all probably are well aware, pigweed is extremely small seed. It doesn't get any smaller, about the size of a pinhead. How in the world could these devices work on something like that? And so that's one of the main questions we're going to tackle today. From what I know, and that's a dangerous statement, but from what I know so far and what I try to keep up with, there appears to be two main commercial devices in the US. One of them is the seed Terminator, which is what we have worked with. Again, all of these are companies based out of Australia, to my knowledge. And the other is called ReadyCop. So my colleagues in Jason Norsworthy, Tom Barber in Arkansas, and Prasant Jha at Iowa State, they each have a ReadyCop unit and are investigating that. And I'm sure there's others, and forgive me if I've left some other universities out, but and then I think back in 2019 was our first season that we were able to look to use the seed Terminator device. And again, I don't want to slight anybody if there's other products out there on the marketplace. I've seen some advertisement of such, for example, for Weed Hog, but I just am not aware of anybody using or evaluating those at this point in time. So to see how it works in action, here's a little drone video. The impact mills are obviously on the rear of the combine. This is one of our sites a few years back. I would just say there's tons of research still needed in this in our country. Obviously, as you can sit here and think, well, all these were used in Australia, and compare harvesting wheat in Australia and that environment and those temperatures to what we experience in the Midwest or the southern US with harvesting soybean or corn for that matter. But what you can see here is two very distinct streams of dust coming out of either side. And that is the discharge from the seed Terminator itself. So, I don't have any close-ups. I probably should, but it's pulverizing everything that's going through there. And you can see our crew out there gathering research and collecting samples and everything. So again, just like weed electrocution, I have a few comments, and I don't have them numbered in this case, but there's just some slides with pictures and comments. One thing is that I learned early on, and was one of my first impressions, was the success of these devices might, I just say might, because we still have a lot of work to do in a lot of different geographies, but it might be dependent on when you get your first frost. And what I mean by that, green weeds have the potential to clog up some of these devices and cause more problems, and have high moisture content. But at the same time, having said all of that, in our geography in Missouri, where we ran this implement, central Missouri, for several seasons, we never clogged in soybean once. Our first interaction with this device was in wheat to get it kind of set up. We had some of the people from Terminator come over and work with us, which we were very thankful for, and help us with the install and help us get it set up. And this was the actual field of wheat. As you can see, it doesn't look like a whole lot of wheat. It looks like a whole lot of water hemp. And there's a lot of water hemp coming up. So this would be in our geography, this is around mid to late June when we're harvesting wheat. In this case, it was late June. And by then, there's plenty of opportunity for some of our summer annual weeds to come up, and we often get some of this green material down below. And so I'm just telling this kind of story to you because that situation didn't work out for us, and we were highly concerned because we got clogging immediately from all that green water hemp in late June, and we're just very concerned about, was this ever going to work for us in our environment? And as I've already said, though, I'll just fast forward here a little bit. We did 2 seasons worth of harvesting in soybean in Missouri. Some of the fields we harvested were before we ever got a frost. Some of them were after, and we never plugged up once. So we did work on this and get it adjusted enough where this did not occur. But Tom Barber and Jason Norsworthy, working with a different implement at the same time back in 2019 and 2020. They were working with the integrated Harrington seed destructor, and they were having all kinds of problems with it clogging. And so these are some of the pictures they shared with me. And again, this was before the first killing frost with Palmer Amaranth in Arkansas. And this is after a frost, and a video that Tom sent to me and shared with me. And as you could see, everything was working fine after they got a frost, but that might not be realistic in some fields in the Mid-South to wait until a frost. And so I know Jason and Tom are both working more with kind of moved on to the ReadyCop unit and perhaps using desiccants and things like that. So much more to come on that. Another comment that I'll state we learned right off. This is kind of a slow motion video of a header going over the soybean as it's harvested. So my camera is literally embedded in the ground here. And in this particular field, you saw some velvet leaf. I don't know how good a weed scientist you are that you could identify those pods, but that's what it was. So there was some velvet leaf there that obviously was mature, and all these things raining down on it are seed, and not only seed, but seed that doesn't make it into the combine at all because it's landing on top of us, as you can see. A good portion of it's not making it into the combine. So one of the things we first learn is there is, just as a result of that process, there is what we can call header loss of, obviously the one we care about most in the US is the pigweeds. And the one I care about most in Missouri and the Midwest is water hemp. And so these are all the locations that we harvested over those 2 years, and the degree of header loss of water hemp seed, if you will. So this is kind of the, everything's kind of got a good news, bad news. This is kind of some of the bad news. The bad news is that at least so far from what we've seen, in our research, there is going to be some water hemp seed that's in that field that never makes it into the combine. And so that's bad from the standpoint, if it doesn't make it into the combine, we can't grind it up and spit it out the back. So maybe there can be some things done. Probably some engineers out there are thinking right now, I could solve that problem. You know, if so, I'd encourage you to contact me or somebody, and maybe we can come up with something that can get more of that seed into the combine. And I should have mentioned, this is all these data slides. Again, I'm not going to show a whole lot of data, but I am going to show some, and all of this is a result of research that another of my grad student is completed and getting ready to graduate. Travis Winans has put all of this data together. Another impression, I guess we're on number 3 here, is that this is just one of our pans that we use to collect whatever comes out of the back of the combine. And if you look close enough, you see a bunch of black dots down in there, and those are all the weed seed. And so the good news part of this is that the majority of, while we do have header loss, the majority of weed seed do enter in and pass through the combine as a result of normal threshing operations. So pretty obviously the converse of what we just showed, of 31% is lost, 69% makes it out of the back. And so this is kind of all the collective data from all those locations across the two years. And again, there's going to be I think the reason we're showing it this way also is because you can see the degree of variation. I'm just giving you averages, but there's going to be variation based on when the field was harvested, what kind of weeds there are, environmental conditions, everything. So, and the question might be, well, how do you know it's not viable? Well, this is just a close-up through a microscope of kind of what we did on these samples to classify them as damaged or not. I'm probably getting a horse before the cart here a little bit, but I'm going to show you damaged seed in a second, how much of the seed is damaged that exits. But before I get there, I guess I will just show you what damaged seed looked like. So we classified some of these, or if it was classified as damaged by us, more than 50% of the seed coat had to be destroyed, or it had to be, less than 50% of the size of the original. So you can see here some of the damaged seed lined up beside some of the non-damaged viable seed in these samples. So it took quite a bit of time to process all of this. And so this is just what across all those locations, what comes out of the back. And again, I'll give you averages, but you can also look for yourself and just see that 74% of the water hemp seed exiting combine is damaged. So again, that's more good news, but those of you that are kind of cup half empty might say, well, it's kind of bad news. It's not killing everything. It's not grinding them all up. And I would agree. They're, part of the message all my whole career is there's really no silver bullet, and that applies here for this as well. But certainly we can get a substantial reduction of the seed that would normally go through a combine. The majority of the seed will be, ground up and beyond viable. So while I tend to focus on water hemp, I get it. Not everybody has got that Achilles heel that we have here. But just to give you some other weeds, it perhaps looks even more promising on some other weeds that are bigger seeds, velvet leaf, morning glory, things like that. So our numbers are even higher for those species. And so, like I said, the good news, kind of bad, just depends on how you look at it, but I'll just choose to be optimistic. The majority of weed seed that enters the combine does pass through and make it into the seed terminator. And most of that comes out of the seed terminator is damaged beyond being viable. So to me, all of that is good news and what we need to hear. Just kind of one of the last comments. We did evaluate combine performance through all of the computer and engineering feats that are available on these combines today. And I do have to give a shout out to Case IH. These are, this is an 8250 Class 8 combine, brand new, that we were able to lease and use from them for this whole project. And we couldn't have done it without them. But what we're able to do is kind of set the computer each time we went to these locations and just kind of harvested big blocks with the seed terminator engaged and with it turned off, and compare those two. And so we found that, I guess no big surprise if you start to think about it, there is going to be greater fuel consumption. The engine load was higher, although we never clogged and you could barely even tell it, but the computer says it was higher. It is pulling a little more on the engine. It was 0.24 miles an hour slower. So a quarter of a mile an hour slower across all these locations when we average it all out, which, you know, it's pretty similar as far as your speed of harvest. So it's hard to, I don't know how many people could detect a 0.24 mile an hour difference. And the last comment on this before we're done and we can have questions hopefully today is that this is kind of the ultimate what we need to know, right? This is what is the density of water hemp plants in the soil following harvest at all these locations. And you know, what I would say as a summary overall is that if you have locations that are already high in water hemp density, like over here at New Florence, Missouri in 2020, for example, or even Hallsville in 2020, you can see we're talking about, you know, 100 plants per soil core that we took and all of that, 150. Well, after one season of use, we did not see any reduction, any significant reduction in the soil in those locations because they already had such high levels to start off with. But if we go over there and compare that to Montgomery City in 2020, you know, we only had 20 plants per soil core and we reduced it to less than 15. So we did see a significant reduction in just 1 year. But I think the really good news here is that when we had some of these locations, we could do 2 years in a row, 2 consecutive uses of the device in Columbia and New Florence, we did see substantial, significant reductions in the soil seed bank. And that's what we're after. That's what these are all about. And so that was good news to see that result. And so this just repeats what I've already just said to you. You know, if you've got a field like this with this kind of density that you see in the spring, you know, one season probably is not gonna do it. But several seasons, you're gonna see some substantial reductions over time. And again, there is no silver bullet. Firmly believe that even with this technology. I'm probably not doing very good justice to the remainder of the harvest weed seed control practices because all I've got is like 2 slides and they're just pictures. But you know, I know Lauren down in LSU, weed scientist down there, is doing a lot with chaff lining. I know Prashant at Iowa State is doing some, but this is another thing we've looked at a little bit in Missouri, and I'm not an expert, but basically chaff lining is another tool that is taking all the chaff and weed seed and putting them in a row behind the combine. And then some people have looked at burning, as you can see here, the burning of the chaff rows. That's what they do in Australia. Other people are just looking at basically placing them in that row and then having some kind of alternate management practice in that row itself. These are pictures from Prashant Jha at Iowa State of some of his work. You can see there's quite a bit of weed seed, of water hemp seed that was found in this chaff line picture on the left. And so basically you're concentrating all the seed right in one location so you can deal with it there. And there's still questions about, you know, how are we going to deal with the chaff line and the weed seed in that row, but at least you don't have it all spread out all over. So that really brings me to the end, and you know, pretty general result or conclusion comments here, but I believe that we need to start thinking different in U.S. agriculture as far as weed management. If you go to any retailer, consultant, farmer in the U.S. today, they basically just want to hear about what's the next herbicide that's going to solve my whatever resistant weed problem. You know, and every day it seems like we start having a new resistance in water hemp or palmer amaranth. I think we're going to have to change that mindset, and it's going to have to include things like harvest weed seed management, whether it's electrocution goes anywhere, whether who knows what the fate of these seed Terminator, seed destruction devices are. Maybe chaff lining plays more of a role, but all of them, I think, are something we're going to have to think about for how we use these in the U.S. for one thing, but how can we get them implemented more to combat this resistant weeds problem, which just is not sustainable the way we're doing weed management right now. And so just want to acknowledge all of these different sponsors of this research, whether it's our local Missouri Soybean Board, whether it's United Soybean Board or North Central Soybean Research Program. They all have funded different parts of this that I've presented today. Certainly for us, Seed Terminator was generous in allowing us to use their device, and Case IH, as I already said, for allowing us to use their combine. So this is my contact information and our social media sites. I'd encourage you to log on and become a follower, because I think all of us nowadays are using these kinds of things to put out information primarily through social media. So with that, I'm going to stop sharing, I guess, here and see if we have any questions to answer.
Thank you, Kevin, for sharing that insightful information about weed seed management practices. So yes, we did have some questions. So the first question is, does the weed zapper kill roots? The weed roots, I guess.
So I think I recognize that name. And Harry, good to hear from you. I hope you're doing well. And there's some research out of the 70s and 80s that looked a little closer at the actual roots and showed that there is kill, Harry. We did not go that much into detail to actually include that as one of our evaluations yet. Maybe we should, I don't know. But every time I've looked at it on my own, I mean, like if you see a plant that's controlled well, like a water hemp species, it's just completely brown, there's nothing there in the roots. They're dead, in my opinion. That question becomes a little bit harder if we see a water hemp that didn't get controlled as well, because in that case, obviously I would say we probably didn't get to the roots, but trying to figure out why that is something we're probably going to focus on moving forward, because we kind of just started this project to see what we could get out of it, and now we just have created more questions and have some more questions to answer. So it's a good question, but for the most part, I would say yes, it does kill the roots. Now, I'm not going to say that I can't guarantee that for, say, let's just say Johnson grass or something like that. I would doubt that it kills the roots of some of our tough perennial weeds.
Thank you, Kevin. So Another question is kind of related. If your weed roots are in contact with crop or soybean, in this case soybean roots, can the electricity cross over from weed roots to and damage the soybean even if you don't contact the crop above ground?
You
So
all have some great questions. I don't know that I have all that great of answers. It's something when I just said we're looking at what are some of our questions and what some more things we can answer this year. My focus this year is to understand how much electricity actually goes into the soil, and that would probably be somewhat related to that answer to your question there. I do not know, but so these are just all great things that we need to try to get an answer for.
another question that we have here is there a research to do see and electrocute possible that may allow for early application of this technology and prevent crop injury?
Yeah, so great. I mean, there's no research that I know of yet, but I think I'm thinking right along with this person, whoever it is that said this, because I think that's where this perhaps needs to go. If some more engineers could get involved. I'm not an engineer, but obviously one of the biggest disadvantages of what we have available to us through this electrocution is that you got to have this height differential and all of that. If we could get it down in between rows and maybe even get it on a see and electrocute, not see and spray, see and electrocute type of system, sure, I could see that being valuable. And I know there's a European country, a European company out there. I think they're called Lasco, and I think they are maybe even have some between row devices. I don't know where their research is yet. I know with the company, the Weed Zapper company, they were looking to also get into that kind of space of not just having a solid boom across the top, but maybe getting between the rows. So great question. I think we're headed that way. I would love to see more research directed that way. And we got enough smart people that can make it happen. But to my knowledge, there's none of that going on yet.
Thank you, Kevin. So the next question is kind of a comment, more rather than a question. So it's isn't 74% seed damage a good news, because it can reduce the selection pressure for years to come?
Absolutely. I love that. I wasn't trying to be negative. It's just that when I have shown some of these results, sometimes to farmers, I do get the, I kind of get the comment back, well, is it really worth it? That doesn't sound like it. I think everybody's expecting that it's, 100% and it's going to be, and nothing's 100%, right? So, but yeah, anytime you can reduce seed numbers by that much, that's that fewer weeds that you're selecting, and so it's a great thing. So it goes to my last comment of, I think all of these have a place in U.S. agriculture, and we just need a little more research to figure some of these things out. But anything that reduces the seed going back in the soil is valuable for sure.
All right. So next question is kind of a long, so I'll try to see. Did you evaluate the impact of management that has been used season long, chemical, non-chemical, on final measured response or kind of seed viability?
Yeah, so this person sounds like a scientist. So we did evaluate electrocution on viability, and we used a classification system for the seed that we screened out of the seed destructor. Basically, that slide I showed with all the seed were in the microscope, and so we didn't plant that seed out, but I would be very surprised if that seed that we call damaged could grow, because we had some other literature that said anything damaged to that degree would not germinate.
I think this question is more towards like at the end, is this many approaches, when we ask for season-long control, or do they remain cost effective at all? Is anybody working on that, if you know?
Yeah, so the cost effective part is very difficult. We're trying to get out of to get at it, excuse me. I don't know how successful we're going to be because, but we are working with an economist on the seed Terminator as far as taking our results and saying kind of how cost effective this over time. And the challenge is, not to get too much into the details here, but the challenge is putting a dollar value on a resistant weed, which we haven't done too good at in our Weed Science Society. Like, for example, what does herbicide resistance in water hemp cost me? Or you take it even further and you could say, what does losing a mode of action cost me? And it's some pretty high level economics that certainly I'm not there yet, but we're working with some people and hopefully that'll be a part of this final ultimate when we're going to be done here in May with it, with summarizing all of this, and the student's going to graduate. We can tell you how much it costs this implement, and I'll just say it right out for the audience. They're going to run you somewhere between $70,000, $75,000, $80,000. I mean, that's the last I've heard. And to go on to your combine. And so I guess as a grower, you tell me, from what I just presented and showed you on how much seed that you can reduce going back into your fields, how many years do you think it would take you before it would pay for itself? So that's kind of the question we're trying to get at, and maybe what this person is asking. I don't have an answer for you yet, because it's pretty tough to figure out, but we're trying to work on it.
The next question here is, can you share how much was the seed retention on the mature plants of weed species under this study? And what is the minimum seed retention requirement for harvest weed seed control?
Yeah, so I mean, obviously we have a range. I don't know it off the top of my head, but it's high. I mean, I could go find the results in this work if I gave me a few minutes, but the seed retention, we had done some research years ago not just me, but actually it was probably like 15, 20 different universities around the US. And one of the things that came out of that research that kind of led to all of this was that Palmer amaranth and water hemp retain a high percentage of their seed. And that's good news because we want it retained on the plant at soybean harvest. When I say high, I'm saying, 90s, high 90s, 90, I know Palmer was probably even higher than water hemp. It was like 98, 99%, but so it was high.
So another question that we have is like kind of, by targeting these taller weed species, escapes, we might be selecting for, the prostrate or, low growing weeds. And I think you answered that question already by saying that there is no silver bullet. So we can go to the next question. And there has been, even resistance or biotypes, resistant to hand weeding in Asian rice culture. So that we can go to the next question here. So the next question is, the smaller plants were not killed because the electrocution was not touching them, or the electrocution bar was not touching them, right?
In many cases, yeah. So I think that's the problem. Well, it's either that we're not touching them, or you're at such an early part in the season that more can come up that weren't even there and germinate after. And so yeah.
So the other question that we have is, the European Zapper targets soil. I didn't understand this question, but I think.
Yeah, it's again my good friend Harry Streck, and he's telling me what the European version does. I think he's saying that it actually targets the soil instead of the plant. So I'm not as familiar with that device. I'm sure Harry is.
So the next question that we have is, what is the cost of using electrocution compared to herbicides? I think you tried to answer that earlier.
Well, I didn't really. I mean, so the device that we have is is a maximum of 15 foot. It's a $40,000 unit, $45,000 unit. Obviously, they cost more the bigger boom that you get. So you would just have to factor in what that initial cost is and your time to go over the field and compare it to herbicide.
So the next question that we have is, when do you forecast these techs becoming available for growers to use in US?
Yeah, well, of course, you can buy them all commercially now. Not anybody that I know of that's not organic is using electrocution yet. But there could be people. There's specialty crop and organic growers that are using electrocution. As far as the seed destruction devices, they are for sale. I think the last I heard, there's 2 farmers in the US that own and use seed Terminator already on their combines. Of course, there's several university people are evaluating these. And then ReadyCop, I think they're probably even a little more popular. So we're talking about very, very low adoption right now, very low numbers. But you could, I'm sure you could find somebody to sell you one.
So the other question is, can we use it on other crops?
Certainly, yeah. And a big focus of our 2022 research is to what extent these would work in corn. And when I say work, I mean, I know they'll work. I guess the question we're going to try to answer is, to what extent the weeds enter into the corn header. Wheat, obviously that's where it all started in Australia. You know, you would think that these would help with some of the weed problems that we have. Weed grasses come to mind as far as they have seeds on them when we're harvesting wheat. So they could help us out, like with the brome species, with the ryegrass, all of that. So anyway, yeah, definitely. Yeah, we just started with soybean.
And with that, I think Harry was confirming that, yes, you were right. It's targeting the soil. So I think we have reached to the end of this presentation. So that concludes our webinar today. Thank you again, Kevin. And thank you all for coming. As I mentioned before, you will be receiving an email with the recording of this link for the recording of this presentation in next few days. And the recording of this session will be available along with other webinars that we presented on the website www.iwilltakeaction.com. With that, thank you everyone.